We are not given a good life or a bad life. We are given a life and it's up to us to make it good or bad. Good morning, my dear students, and welcome to a new session of our online class. Today, let us begin chapter number 3, Laws of Motion. This is an easy chapter, but one of the longest chapters of the book. All are familiar with the term force. When you are writing with your pen on a book, you are exerting force on your book. When you are sitting on a chair, you are exerting force due to your weight. When force is applied on a body, it can produce two main effects. Number one, it can change the state of rest or of motion of the body. Number two, it can change the size or shape of the body. Let us understand both these effects better. Number one, force can change the state of rest or of motion of the body. This effect of force can be divided into three categories. First, force can produce motion on a still body. For example, when a football player takes a penalty kick, initially ball was at rest while the player exerted a force with his leg, ball started moving. So, force can produce motion on a still body. Number two, force can stop a moving body. For example, when the goalkeeper holds the football that was kicked by the player, the ball that was moving or that was in motion came to a stop when a force was exerted by the goalkeeper. So, force can also stop a moving body. Number three, force can change the direction of motion. For example, when football match take place, players kick the ball and direction of ball changes every time a player kicks. Thus, a force can move a still body, it can stop a moving body, and it can change the direction of motion. Now the second part, force can change shape and size of the body. For example, take an inflated balloon and press it with your hands. On applying force, shape of the balloon changes. Let us take another example. Take an elastic strip or a rubber band, pull it by applying force on it. You can see the size of it changes. So, we can conclude a force can change the dimensions of a body. Now we have understood what a force can do. A force can move a still body, can stop a moving body, can change direction or change the dimensions of a body. So let us define force as follows. Force is that physical cause which changes or tends to change either the size or the shape or the state of rest or of motion of a body. Please note, if no force is applied on a body which is moving, it will continue to move. And a body which is at rest, it will continue to be at rest. Now the question is, what happens when force is applied on a rigid and a non-rigid body? What is a rigid body and a non-rigid body? Rigid body is a solid body whose shape and dimensions cannot be changed easily. For example, a table, a chair, stone, wood, etc. A non-rigid body is a body whose shape can be easily changed. For example, balloon. A force when applied on a non-rigid body changes its shape and dimensions and cause motion in the body. And when a force is applied on a rigid body, there is no change in the shape and dimensions but only cause motion in the body. Now let us study different kinds of forces. From the point of view of application of force, it can be classified into two categories. Number one, contact force, and number two, non-contact force. Contact forces are the forces applied on bodies by making physical contact or by direct touch. There are many types of contact forces. Let us study 5 important types of contact forces. Number 1, frictional force or force of friction. If you roll a ball on the floor or ground, after some time the ball stops. We know there must be a force to stop the body. There are two forces acting on the body. One is gravitational force and the other is frictional force. Let us forget about gravitational force because it is always there on the earth. Then what is frictional force? When the ball is moving, outer surface of the ball is in contact with the floor or ground. This floor or ground exerts an opposite force to the ball due to contact. This force is called as frictional force. Now if you pour oil or water on the floor, ball will not stop that fast because now this oil or water has decreased the force due to friction. Another example, you are able to write with a pen or pencil due to friction. If paper is wet with oil, you may not be able to write easily because of less friction. Now the second type of contact force, normal reaction force. When you hold a 1 Newton of weight in your hands exerts an equal 1 Newton of force upwards. Due to this, the weight of 1 Newton is balanced by the force exerted by your hands. This type of force is called as normal reaction force. Now the third type of contact force, tension force. Please don't confuse this term with the tension that you are having before the examinations. That tension is a psychological phenomena, whereas this tension, what we are speaking about, is a physical phenomena. In normal reaction force, we balanced 1 Newton of weight using our hands. Now if that weight is hung on a string or a rope, string or rope exerts an equal but opposite force to balance the weight. This force, which is exerted by the rope or a string on an object, is called as tension force. This force is very important for examinations. Diagrammatic questions and short answer type questions may possibly ask from this part. And now the fourth type of contact force, force exerted by a spring. Take a spring and fix one of its ends. Now if you compress the spring or stretch the spring, we can feel an opposite force exerted by the spring. This force is called as force exerted by a spring. Now the final type of contact force, force during collision. Let us take an example. A body, let it be a car, moving fast and hits on a fixed wall. What happens? After hitting, car moves backwards. Who pushes the car backward? Obviously the fixed wall. So, during collision, force was exerted by a car to the wall and wall exerts an equal and opposite force to the car. This force is called as force during collision. Now let us study about non-contact forces. As the name suggests, this force happens even without any contact. The forces experienced by bodies even without being physically touched are called as non-contact forces. or it can be also called as forces at a distance. Mainly there are three types of non-contact forces. Number one, gravitational force. I know everyone knows about it. Remember, an apple falling on Isaac Newton's head is due to gravitational force. Second type is electrostatic force. We have already studied two like charges repel and unlike charges attract. If you rub a plastic scale with your woolen cloth and then take this plastic scale to bits of paper, scale will attract these bits of paper. This is due to electrostatic force. Now the third type of non-contact force is magnetic force. Force exerted by a magnet is called as magnetic force. Remember, similar poles repel and unlike poles attract each other. Let us conclude with the general characteristics of non-contact force. Number one, gravitational force is always attractive, whereas electrostatic force and magnetic force is both attractive and repulsive. Number two, non-contact force is more when distance between the force is less, and when distance increases, force becomes lesser and lesser. So, non-contact force is inversely proportional to square of distance. So, on doubling the distance, force becomes 1/4. That means force is proportional to 1 by d square. That means F is proportional to 1 by 2 square because we have doubled the distance. Therefore, we will get F is proportional to 1 by 4. Force became 1/4. So that is the end of today's class. Life is not about quantity of friends you have. It is about quality of friends you have. With this thought, let me conclude. Thank you. Have a great day. May God bless you all.